continuation from where we stopped, right? Continuation from where we stopped, right? In our previous class, we've seen the concept behind power series solution of differential equation, right? Meaning the whole concept is that finding the higher derivative, meaning say you have a product function, you want to find the higher derivative, you can make use of binomial expansion, right? We've discussed all of this previously, meaning in our last class we've seen the whole concept, right? And we were able to find the nth derivative of a given question, right? So you are given a question says that find the nth derivative. How do you go about it? We've been able to do that, right? So for today's class, we'll be finding the nth derivative of a differential equation, right? I said for today's class, we'll be finding the nth derivative of a differential equation. Say you are given a differential equation. Question says that find the nth derivative. How do you go about it? Same idea, right? Now, given this differential equation, the question says that find the nth derivative. We call that we've generalized a series solution for our nth derivative of a product rule, right? Say you have y is equals to uv. Of course, this is a product function, right? Question says that find the nth derivative. By nth derivative, meaning if y is this, it implies I'm looking for y raised to the power of n, right? And we've derived the formula, meaning the general formula for nth derivative of a product rule, right? Let's recall this formula. This formula says that, just observe that I'm having u and v as a function, right? The power of my u is having n as its power, right? Where the power is decreasing, right? Where v is increasing, meaning I have the first function, differentiate the first function, differentiate again, right? So let's recall, we are saying that given y, say this is equation 1. From equation 1, what's the nth derivative of equation 1? We call that the nth derivative of equation 1 is given as u r raised to the power of n multiplying v, right? Plus n multiplying u raised to the power of n minus 1 multiplying v raised to the power of 1, right? Plus n all into brackets n minus 1 all divided by 2 times 1 multiplying u r raised to the power of n minus 2 multiplying v raised to the power of 2, right? Plus n all into brackets n minus 1 multiplying n minus 2 all divided by 3 times 2 times 1 multiplying u all raised to the power of n minus 3 multiplying v all raised to the power of 3, right? Continuously we have that same pattern. Just observe that you have two functions, right? You have two functions multiplying itself, meaning you have this product function. In this case, this is my u. The power of my u is expressed in terms of n, right? The power of my u is expressed in terms of n, where the power is decreasing. Meaning, initially, I started with what? N, right? I started with u raised to the power of n. Moving on, I have u raised to the power of n minus 1. Next up, what do I have? U raised to the power of n minus 2. The next one becomes what? U raised to the power of n minus 3. If I'm to continue with this series solution, the next one becomes what? U raised to the power of n minus 4. That's for my u function, right? Similarly, observe the power of your v. You are having the initial function itself, meaning v as a function. Differentiate your v, meaning the first derivative. Moving on, you have the second derivative, you have the third derivative, and you have the fourth derivative, right? We've seen the concept behind this series solution. And we said this solution, in terms of this n derivative of a product function, we can write it in terms of series solution, right? We can write it in terms of series solution. We've seen that we can write this general solution in terms of what? Series solution, right? So meaning that given a question, first thing first, say you are given a differential equation. You want to find the nth derivative of the differential equation. First thing first, we call this formula. By the time we call this formula, all we'll be doing is substitution, right? All we'll be doing is substitution. Just like the way we've seen for the first example we had. Just that we are doing substitution, right? Now, given this question, I can separate this question, right? You know, this is a differential equation. This differential equation, I can write it as 1 plus x squared y prime, right? Negative 3x y prime minus 5y. Where the square y over the x squared is equals to y prime and the y over the x is equals to what? Y prime. So that's what we did here. Meaning, given a differential equation, our first step is to write it in this manner. write it in this manner. So we'll be working with this. Say this is equation 1, say this is equation 2. Meaning we'll be working with equation 2. We want to find the nth derivative of this differential equation. We'll be working with what? Equation 2, right? Then I didn't know that if I'm having two functions multiplying itself, say u and v, this is the nth derivative, right? This is the formula for the nth derivative. Meaning, given this differential equation, I can apply the same idea, right? I can apply the same idea, treating this very term. I'm having three terms here. I'm having three terms here, so summing up each other. I'm having three terms here, summing up each other, right? So implementing this idea, I can take this as u and v, right? Take this as u and v. Take this as u and v. Meaning, whatever formula that I know for the nth derivative of a product function, which is u and v multiplying each other, I can apply it to this very first term, to this second term, and to this third term, right? So we are saying that given this question, we assume, or we say let w equals to 1 plus s squared multiplying y prime prime. This is the first one. The second one, say w is equals to negative 3xy prime, equation 2. Then the third one, say w is equals to negative y, call this equation 3, right? What we just did here is that since I already have the understanding that given y equals to uv, meaning a product function, this is the nth derivative. Similarly, I can say that w equals to this, where this becomes u, where this is what? V. Likewise for equation 2 and for equation 3, right? Now, taking the first one, which is equation 1, meaning w1, I want to find the nth derivative of w1, right? Just have it in mind that this is the formula I need. Say you are given a product function, you want to find the nth derivative. First thing first, record this formula. By the time you record this formula, you are doing substitution. By the time you record this formula, the next task is what? Substitute, right? So you are saying that given that w, meaning w1 is given as 1 plus x squared multiplying y prime prime, right? I want to implement this equation. From this formula, I'm having two functions which are what? U and v. Now, meaning I need to identify my u and I need to identify my v. The question is, what is my u and what is my v? Or how do I identify my u and v? We said when it comes to you identifying your u function and your v function, the idea is very simple, right? The first example we did was that given these two monomials, right? This is a monomial function where this is u, where this is v. Say you have this, observe the functions. Meaning by the time you start differentiating, the whole idea of power series ordinary differential equation is that we are doing higher derivative. Meaning binomial expansion is equals to what? The higher derivative, right? Now given these two functions, you want to identify your u, you want to identify your v. How it works is that take these two functions, differentiate, meaning start doing your higher derivative. By the time you keep doing derivative, meaning you keep differentiating, you keep doing your higher derivative, one of these steps becomes 0, while the other one it keeps going in a concurrent manner, right? I said you want to identify your u and you want to identify your v. How it works is that take these two terms, differentiate, meaning performing your higher derivative. One of these two terms you end up getting 0, while the other one you keep differentiating. So the one that gives you 0 at the end, take it as v. Take it as what? V. While the other one that keeps going in a concurrent manner, take it as what? U. While we're taking it as u, back to what we have here, we've seen that u is just decreasing, right? Meaning the power of u is just decreasing. Meaning this is u raised power of n, u raised power of n minus 1, u raised power of n minus 2, u raised power of n minus 3, u raised power of n minus 4. But you understand this better when we solve this question, right? Now, let's say we have 1 plus x squared and we have y prime prime. Now let's differentiate this. I want to identify my u and I want to identify my v, right? Let's differentiate this very guy. By the time we differentiate this, meaning the first derivative, what do I have? I have 2x, right? Differentiate, meaning second derivative, what do I have? I have 2. Then lastly, what do I have? 0. Similarly, let's differentiate this very guy. Meaning, just observe from here, I'm having y prime prime, right? Just take note of how you do your derivative for your differential coefficient. Now, if I'm having y prime prime, your derivative becomes y raised to the power of n plus 2, right? If I'm having y prime, meaning the third derivative, your derivative becomes what? Y raised to the power of n plus 3. Are you getting me? If I'm having y raised to the power of 4, meaning the fourth derivative, your derivative becomes what? Y raised to the power of n plus 4. So that's how it works. So let's differentiate this. My first derivative is what? Y raised to the power of what? N plus 2, right? Let's differentiate this again. What do I have? Y raised to the power of n plus 1. Y raised to the power of n plus 1, right? Meaning I'm having y raised to the power of n plus 1. Meaning the power is decreasing. Just like we've seen here. We started with what? N. We started the power with n. Moving on, what do I have? U raised to the power of n minus 1. What do I have? U raised to the power of n minus 2. U raised to the power of n minus 3. U raised to the power of n minus 4, right? Continuously, you have your u function, right? Similarly, I'm having y raised to the power of n plus 2. What does it mean? It means the power keeps decreasing. If you are starting with n plus 2, the next one becomes what? N plus 1. The next one becomes what? N. The next one becomes what? N minus 1. So that's what we are saying, right? So meaning from here, I have y raised to the power of n. What do I have again? Y raised to the power of n minus 1. Y raised to the power of n minus 2. It keeps following that particular pattern, right? So the question now is, with what we've done here, which one is my u, which one is my v? Say this is 1, say this is 1, say this is 2. Between 1 and 2, which one is u, which one is v? 2 is what? U. Y1 is what? V. That's it. 2 is U. Y1 is what? V. Why is 2U? 2 is U because it keeps going in a concurrent manner. Meaning the higher derivative, you keep having it in a concurrent manner. Meaning it does not end. But for V, when we do the third derivative, it goes 0. Meaning it has ended. So we are saying that giving question of this nature, you want to identify your U and you want to identify your V. The one that keeps going in a concurrent manner, take it as U. Why the other one that are going to get 0 by the time you start doing your derivative, take it as what? V, right? So we are stopping our derivative at this third derivative. We said, since we've identified that this is my V and this is my what? U. Meaning we are going to stop our derivative, meaning our derivative, the higher derivative, we are going to stop at the third derivative. Why are we stopping at the third derivative? We got 0 for this very guy. Meaning, at what point, or you say at what derivative do we get 0? At the third derivative. We got 0 at the third derivative. Meaning, it implies for this other one. Let's say we got 0 at the fourth derivative. Meaning, you also stop at the fourth derivative for this. Are you getting me? So that's how it works. So we said, given this question, we want to find the nth derivative. This is the given question. We want to find the nth derivative. This is my v, this is my u. By the time you start differentiating, you have this, right? Now, we said, are we together? You know, given this question says that find the nth derivative. Find the nth derivative. By nth derivative, this is the formula we are following. By nth derivative, this is the formula we are following. Meaning, once you've written out this formula, I want to do substitution. I want to do what? Substitution. Now, doing my substitution, how it works is that the nth derivative for this question, the nth derivative of this question, I'm having w equals to this, meaning w1 raised to the power of n, right, equals to, now identify, was in this case u raised to the power of n is what? Following this question, what will be u raised to the power of n? U raised to the power of n. Why? U raised to the power of n. You know, this is what we want to do. Given this question, we want to find the nth derivative of this question using this formula. Meaning I'm doing substitution. I need my u raised to the power of n, I need v, I need all of these terms, right? All of these functions, right? Now, doing comparison with what we've differentiated so far. In this case, what is u raised to the power of n? Y? Exactly. Y raised to the power of n plus 2. Y raised to the power of n plus 2. Right? Just follow what I'll be doing now. Follow what I'll be doing for easier understanding, right? Now, from here, I want to differentiate this very guy. I've identified my u and I've identified my v. Now, I'll be starting with u. I'll be starting with what? U. Me starting with u, I'm interested in the power of the derivative. You know, in this case, I'm having prime. Meaning, I'm having y raised to the power of n plus 2, right? I'm having y raised to the power of n plus 2. Moving on, what do I have? V. What might be in this case? 1 plus s square. 1 plus s square, right? So, right. 1 plus s square. Moving on, what do you have? You have n. Right, n. Meaning plus n. right? The next one is what? U raised to the power of n minus 1. The next one is what? U raised to the power of n minus 1. Just observe the way it works. You know, in this case, you started with u raised to the power of n. The next one becomes u raised to the power of n minus 1. Moving on, u raised to the power of n minus 2, u raised to the power of n minus 3, u raised to the power of n minus 4, right? So if you are starting with y raised to the power of n plus 2, the next one will be what? Y raised to the power of n plus 1. Y raised to the power of n plus 1. And we've seen that from what we've differentiated. So we are saying n multiplying y raised to the power of n plus 1, right? Multiplying v prime. What v prime means is that the first derivative of the v function, right? If this is v, this is the first derivative, 2x. Or you can just come back to what you have here. This bracket, differentiate it. By the time you differentiate this, what do you have? 2x. They are saying multiplying by 2x. So after this nth derivative of a product function, we've done for this term and we've also done for this term, right? Moving to the next form, which is the third term. I'm having n all into brackets n minus 1 all divided by 2 times 1. So you are going to write that. Meaning you are doing repetition. Meaning from here, what do I have? Plus n all into brackets n minus 1 all divided by 2 times 1, right? I'm saying u raised to the power of n minus 2. In this case, it becomes what? Y raised to the power of n, yes. Y raised to the power of n. Meaning we started with y raised to the power of n plus 2, y raised to the power of n plus 1. The next one becomes what? Y raised to the power of n. Y raised to the power of n. Meaning I have y raised to the power of n. Right? Multiplying by what? V squared. Meaning the second derivative of the v function. How do you get? What's the answer to that? 2. Meaning differentiate 2x. By the time you differentiate 2x, what do you have? You have 2. Multiply by 2. Multiply by 2. Right? The next one is what? Plus. I'm having this, but we don't even need to write this. But you see that? You see the reason. Now from here, the next one is what? I'm having this very term, right? I'm having this term. So meaning plus n all into bracket n minus 1 all into bracket n minus 2 all divided by 3 times 2 times 1. U raised to the power of n minus 3 will be what in this case? U raised to the power of n minus 3. You know, the power of u is decreasing. If this is your initial u, which is y raised to the power of n plus 2, the next one, y raised to the power of n plus 1, you are subtracting 1 from it. The next one is y raised to the power of n. The next one will be what? Y raised to the power of n minus 1. Y raised to the power of n minus 1. But you stop here. You stop here. But you see the reason why you need to stop here. Because by the time you differentiate this, what do you have? 0. 0 multiplying this coefficient, we still have 0. So meaning that by the time you differentiate your v function to a constant, right? Given a v function, by the time you differentiated up to a constant, meaning that should be your last step for that n derivative. That should be your last step. Because by the time you say you want to proceed, you definitely get 0. 0 multiplying all of this is still 0. So this is what we are saying. Multiplying y all raised to the power of n minus 1 times 0. And this cancels out. So meaning for this question, the nth derivative of this question becomes what? Y all raised to the power of n plus 2 multiplying 1 plus x squared, right? Plus 2xn multiplying y raised to the power of n plus 1 plus 2 cancel out, right? I'm left with n all into brackets n minus 1 multiplying y raised to the power of n. Multiplying y raised to the power of n. Any question? So the same way we found the nth derivative of the first term. You know, this was the given question. This was the given differential equation. We separated it, applying nth derivative to this, meaning say this is a product function. We got this. The same way we found this. The same way we found this. You are also going to do that for this, and lastly, you are going to do that for this. Then all your answer, you are going to sum it up. You are going to sum it up. Right? You are going to sum it up. But the question itself is that write a series solution for this differential equation. Write what? A series solution for this differential equation. Meaning that you want to write a series solution for a differential equation. Your first step is what? Obtain the nth derivative. Obtain the what? Nth derivative. By the time you've obtained the nth derivative, step 2 is that derive a recurrence relation. Derive a recurrence relation. Or you say obtain a recurrence relation. How do you get your recurrence relation? Substitute x equals to 0 in your nth derivative. Substitute x equals to 0 in your nth derivative. But we did this first so that we can understand how nth derivative works. Right? We did this particular example so as to understand how nth derivative works. In the next example, we are going to find the series solution of a given differential equation. Meaning you'll be given differential equation of this nature, then we write the series solution. Then we are going to what? We are going to write the series solution. By series solution, we are saying that y is equals to y naught plus the first derivative multiplying x plus y prime prime multiplying s2 s square over 2 factorial plus y prime prime prime, meaning the third derivative multiplying s cube over 3 factorial. So this is what we are saying. And when we started this subtopic, or when we started this topic itself, we said Leibnitz Maclaurin series, right? Leibnitz Maclaurin series. When we say Leibniz series is all about finding a product function. It's all about finding the nth derivative of a product function, right? While Maclaurin series is using Taylor series, meaning that I'm going to find the second derivative, third derivative, fourth derivative, but we are going to see how it works. We are going to see how it works, right? Moving on, let's find the nth derivative of this second term and the nth derivative of this third term. Given this differential equation, question says that find the nth derivative, right? By nth derivative, we know what it means, right? Meaning we separated this, we treated this term first, right? Meaning we found the nth derivative of this very term, we got this, right? The next one, we are having this term, meaning we are going to find the nth derivative of this term, then lastly for this term, then sum it up, right? So we are saying that given that we2 is equals to negative 3xy prime, find the nth derivative. Find the nth derivative. Now let's find the nth derivative. Finding the nth derivative, instead of me recalling, normally I would have recalled the general series solution for nth derivative of a product, right? Are we together? I said, given a question, you want to find the nth derivative. My first step is what? Recall the general series solution of the nth derivative, right? But in this case, let's compute the nth derivative directly. Let's compute it directly instead of me recalling, right? By the time we start recalling, meaning we are going to recall for this, and recall for this, but we don't want to do that. We want a faster calculation, right? So we are saying that given this as a term, we want to find the nth derivative. Let's compute this directly, right? How do we go about it? In this case, identify your u, identify your v. Let's treat this as constant. Negative 3, let's take it as constant. Meaning I'm having negative 3 multiplying x y prime. So I'm working with this. Meaning my answer, I then multiply this with it later, right? Now I'm having x and y prime. What's my u, what's my v? I'm having x multiplying y prime. What's my u, what's my v? You know how it works, right? So what's my u? My u is what? My u is what? Y prime. My u is what? My u is y prime. My u is y prime. Why is my u y prime? By the time we start differentiating y prime, we have a recurrent derivative, meaning the derivative does not end. But you see for n, by the time you differentiate it first time, what do you have? 1. Differentiating 1, what do you have? 0. Meaning it has ended. So it becomes what? V. So you are saying, given this function, this is my u and this is my what? V. This is my u and this is my v. How do I know that this is my u, this is my v? Say you have x, say this is x, and say this is y prime. By the time you differentiate this the first time, meaning the first derivative, you have 1. Differentiate again, what do you have? 0. Let's differentiate this for the first time. I'm having n plus 1. I'm having this. I'm having y raised to the power of n minus 1. Y raised to the power of n minus 2. Meaning it keeps following that pattern. So meaning this is the concurrent derivative. Take it as what? U. Why this other one? Take it as what? V. Right? Then also take note that I'm going to stop at the second derivative. Why am I stopping at the second derivative? Because at the third derivative for the v function, we got 0. We got 0. Meaning I'm having 0 and y raised to the power of n. So let's solve. We solving, meaning I'm going to start, meaning that the nth derivative for this function becomes, I'm starting with u raised to the power of n. In this case, what is u raised to the power of n? Y raised to the power of n plus 1. Y raised to the power of n plus 1. Just take note that if you have y prime prime, you'll be starting with y raised to the power of n plus 2. If you have y prime prime prime, meaning the third derivative, you are going to start with y raised to the power of n plus 3. But in this case, I'm having y raised to the power of n, meaning I'm starting with what? Y raised to the power of n plus 1. So if I'm starting with this, I'm going to multiply this by v function. What v function? X. Meaning I'm going to multiply this by what? X. Moving on, what do I have? Check your general series solution. you are having the coefficient of this, you are having it as 1, meaning you are having invisible one here, right? Which is the first term. The next term, what's the coefficient? N, right? So you are saying plus n multiplying plus n multiplying, you know, your y, you started with n plus 1. The next one will be what? Y raised to the power of n, meaning your y is decreasing. So multiplying y raised to the power of n. Then differentiate x. By the time you differentiate x, what do you have? Multiplying 1, right? Moving on, I'm having n all into brackets n minus 1 all divided by 2 times 1 multiplying y raised to the power of n minus 1, meaning your y decrease to this. Differentiate this, what do you have? 0, multiplying 0. So this is out because all of this we still have 0. So meaning from here, the nth derivative is equals to x multiplying y raised to the power of n plus 1, right, plus n multiplying y raised to the power of n. So this is your nth derivative for this particular term. What do you say? Right? So this is your nth derivative for this particular term. Then we have negative 3 here, meaning negative 3 we multiply what we've gotten. So meaning I'm having negative 3 all into brackets xy all raised to the power of n plus 1 plus n multiplying y raised to the power of n. This becomes what? Negative 3x negative 3x y raised to the power of n plus 1 minus 3n y raised to the power of what? Right? Any question on this? No question, right? Now, applying same idea to this last term, I'm having that y3 is equals to negative 5y. y3 is equals to negative 5y, which implies that negative 5 multiplying y, meaning we treat this as constant, then our nth derivative will multiply by this, right? So looking at this function, say you have y multiplying 1, I'm having y, you know, y is still the same thing as you saying y multiplying 1. So let me identify what's my u, what's my v for these two terms. What's my u for this function? What's my u, what's my v? Y is my u and v is 1. You know, this was the question itself, why? But I said, for sake of simplicity, or you say for better understanding, since I know that for n derivative of a product function, I must have two functions, which is what? U and v. I'm not saying that if the given question is y, I can still write it as y multiplying 1. So in this case, what's my u, what's my v? My u is y and my v is what? 1. Meaning from here, I'm starting with my u is y and my v is equals to 1, right? Meaning the nth derivative of this u raised to the power of n implies y raised to the power of n. U raised to the power of n implies y raised to the power of n, meaning no stress. This is your derivative for y. Then for this, the first derivative is what? 0. So let's work with that. So the nth derivative becomes, given y equals to y, the nth derivative becomes what? Y raised to the power of n multiplying the v function itself, which is what? 1, plus your coefficient, which is n, multiplying y raised to the power of n minus 1, multiplying the derivative of 1, which is what? 0, and this cancel out. Therefore, the nth derivative, meaning w3, is equals to y raised to the power of n, and we have a constant here. This constant multiplying the nth derivative, meaning that w3, the nth derivative of w3 becomes what? Negative 5 y raised to the power of n. So we've been able to find the nth derivative of each differential term. This is for the first one, this is for the second one, and this is for the what? Third one, right? So given this question, and the question says that find the nth derivative, what do? Sum all these nth derivatives, sum it up, meaning sum the first one plus the second one plus the third one, then you obtain your answer. Right? So let's do that. Meaning given this differential equation, the nth derivative, say y raised to the power of n, is equals to our first nth derivative was what? Our first nth derivative was what? 1 plus x squared multiplying y raised to the power of n plus 2, right? Multiplying 2n multiplying x y raised to the power of n plus 1, right, plus n all into bracket n minus 1 multiplying y raised to the power of n. This is the first nth derivative. The second one is what? negative 3xy multiplying n plus 1 negative 3n multiplying y raised to the power of n, right, minus 5y raised to the power of n. Any question on this? No question. So let's collect like term. Is it possible for us to collect like term? We are having y raised to the power of n plus 1 and we are also having y raised to the power of n plus 1, meaning y raised to the power of n plus 1 is common. So this implies 1 plus x squared multiplying y raised to the power of n plus 2 plus 2nx, right, plus 2nx minus 2n minus 3 multiplying x multiplying y raised to the power of n plus 1, right, plus all into bracket n all into bracket n minus 1 minus 3n, right, minus 5 all multiplying y raised to the power of n. Any question on this? So meaning this is my nth derivative, this is my nth derivative, and you can simplify this further, meaning by the time you open this bracket, collect like them. Let's do that. This becomes n squared minus n minus 3n minus 5 multiplying y raised to the power of n, right? Then this is what? N squared minus 4n minus 5 all multiplying y raised to the power of n. So instead of writing this, you can just substitute what we've expanded, meaning n squared minus 4n minus 5 all into bracket y raised to the power of n. Any question? Any question? No question. Meaning that we've given this differential equation, this is the nth derivative. Given this differential equation, this is the what? Nth derivative, right? Are we together? So we are saying that you'll be given a differential equation. We'll be given what? Differential equation. You know, when we say differential equation, we can be given second order differential equation, third order differential equation, first order differential equation, any differential equation we can imagine, right? So the question also is that find the nth derivative. By nth derivative, this is how it works. Meaning all we've done so far, the steps remain the same for any given question. So for this very differential equation, this is the nth derivative. This is the what? Nth derivative, right? But I said by power series of differential equation, by power series of ordinary differential equation, we want to write a series solution for our differential equation. We want to write what? A series solution for our differential equation. So meaning our first step, writing a series solution for a differential equation, our first step is what? Find the nth derivative. Meaning step 1, find the nth derivative. So we found out this is the first step. Step 2, substitute x equals to 0 in the nth derivative so as to get recurrence relation. Substitute x equals to 0 in the nth derivative so as to get recurrence relation. So this is what we are saying. By recurrence relation, this is recurrence recurrence relation. By recurrence relation, you know, our series solution is in form of Taylor series, right? Meaning I'm having y, which is equals to f of x is equals to y naught plus the first derivative of y multiplying x plus the second derivative of y multiplying x squared over 2 factorial plus the third derivative multiplying x cubed over 3 factorial. Moving on, you have that same pattern, right? So by recurrence relation, what recurrence relation does is that it helps us to find the derivative of y. It helps us to find what? The derivative of y. Have it in mind that we want to find the series solution of this differential equation. This is what we are saying, right? Where y2, meaning where the second derivative is a function of y, or y prime naught, where y3, meaning the third derivative, is a function of y naught, or when we say y naught, we are actually saying y and the first derivative. We are saying y and the first derivative. So just add this subscript, meaning y naught, and you have this, right? Then moving on, I have this also. So what it means by recurrence relation? By recurrence relation, we are saying that you'll be given this differential equation. You want to write a series solution for your differential equation. You writing a series solution for a differential equation, you need a recurrence relation. What does recurrence relation help us? By recurrence relation, what does it? By recurrence relation, it means that given this series solution, I need y square, meaning the second derivative of y. I need y cube, the third derivative of y. But have it in mind that this second derivative, this third derivative, fourth derivative, higher derivative of y, starting from the second derivative, are always expressed in terms of what? Y and the first derivative. Meaning your y square, which is the second derivative, are always expressed as either y or the first derivative. Similarly for the third derivative, similarly for the fourth derivative. The question now is, how do we get this formula to obtain this? So that's what we call recurrence relation. And how do we get this recurrence relation? Substitute x equals to 0 in your nth derivative. Substitute x equals to 0 in your nth derivative. So by doing that, say you want to find the recurrence relation of this question. Say you want to find the recurrence relation of this question. You know, we've gotten the nth derivative as this. We've gotten the nth derivative as this. Meaning, what we are going to do from here is that, anywhere you see x, substitute what? 0. So I'm having 1 plus 0 square multiplying y raised to the power of n plus 2 plus all into bracket 2 multiplying n minus 3 multiplying 0 multiplying y raised to the power of n plus 1, right? Plus all into bracket n square minus 4n negative 5 multiplying y raised to the power of n. Now let's evaluate this. Let's simplify this. Resimplifying this becomes y raised to the power of n plus 2, and of course this cancels out, right? 0 multiplying all this term, I have 0, plus n squared minus 4n minus 5 multiplying y raised to the power of n, right? So the first step is that obtain your recurrence relation, obtain your nth derivative. Once you've gotten your nth derivative, you want to get your recurrence relation. How do you go about it? Substitute x equals to 0, meaning that if this is my nth derivative, we substitute x equals to 0, we got this expression, right? From this expression, say this is equation 1. If this is equation 1, you know, we said recurrence relation. When we say recurrence relation, meaning recurrence equation. Now I'm having an expression. How do I get my equation? Equate this to 0, meaning equate this expression, which is 1, equate it to 0. We equating it to 0, I have y raised to the power of n plus 2 plus all into brackets n squared minus 4n minus 5 multiplying y raised to the power of n equals to what? 0. Equals to 0. Now I want to get our recurrence relation. I want to get what? Recurrence relation. Is either you say recurrence relation or you say recurrence equation. Now, how it works is that, observe, you know, I'm having y function here. I'm having y function. I'm having two y functions. Meaning this is the first function, this is the second function. But between these two functions, one is having the maximum power, or you say the highest power, true or false. So identify, say this is 1, say this is 2. Between 1 and 2, which one is having the highest power? Is it 1, is it 2? It is 1, it is 1. If n, assume n equals to 1, meaning y is power of 1, meaning this becomes y is power of 1 plus 2. So 1 is having the highest power, right? So from this, say this is equation 2. From equation 2, you want to get a recurrence relation. From equation 2, make y the subject of the formula. Make y the subject of the formula. But observe the highest power of y. Observe the highest power of y. Meaning you are going to make the highest power of y the subject of the formula. You are going to make the highest power of y the subject of the formula. So if this is the highest power of y, meaning I'm making this the subject of the formula. By doing that, it means that this expression is going to the other side. Therefore, I then have, therefore, y raised to the power of n plus 2 is equals to negative, all into brackets, n squared minus 4n, right, minus 5, multiplying what? Y raised to the power of n. And this is our recurrence relation. And by recurrence relation, we are saying that with this equation 3, we are able to get y raised to the power of 2 in terms of y naught or y prime naught. We are saying that with this recurrence relation, you'll be able to get y raised to the power of 3, meaning the third derivative. You'll be able to get the fourth derivative. You'll be able to get the fifth derivative up to the number of the derivative you want to stop. Some question will be specific, and the question will say that stop at the sixth power of x. Stop at the sixth power of x, meaning given a differential equation, write the C solution of this differential equation and stop at the sixth power of x, meaning y raised to the power of 6. If the question says that stop at the fifth power of x, meaning y raised to the power of 5, meaning that with this recurrence relation, you are going to obtain y raised to the power of 2, y raised to the power of 3, y raised to the power of 4, and y raised to the power of 5. So what we are saying in essence is that you are going to stop at the power of x given to you in the question. You are going to stop at the power of x given to us, right? So that's how it works. That's how power series differential equation works.